Here we're going to do problem 418. Go to back up here. Do that problem. So 418, the first thing we're going to do is draw a free body diagram. And that is a beam. And on that beam, now we'll note that A is pinned, so we can think that there's a possibility that we'd have an AY. Push them back up, and that does look like a good possibility. And then we've got maybe the potential for an AX. Whether or not it is, we'll see. Then we've got a force of 8,000 pounds. That is 3 feet from A. Then we've got this evenly distributed load, which is 600 pounds per foot over a length of 12 feet. So we're going to have another force out here. And we said it was 600 pounds per foot times, what did we say, 12 feet. The feet units cancel out and we're left with pounds. 600 times 12, 7,200 pounds. I'll have 7,200 pounds here. Now the distance between these two was 3 feet plus 6 feet, so that's 9 feet. So how is that 3 feet plus 9? Well, there was 3 feet to the front edge of the, or to the left edge of the evenly distributed load, and then you go another 6 feet, which is half of the 12. So you end up with 9 feet there. And we've got another force here. Put one down. That's 3,500 pounds. Distance between those two, now it's again from that edge, we've got 6 feet to the right edge of the evenly distributed load plus 4 feet, so that's 10 feet. And then we go another 3 feet, or excuse me, 2 feet to the BY. There is probably some type of a force pushing back up. And BX is this is on a roller, so BX equals 0. And then, like I said, we had 2 feet right there. So the overall length should be 24, so we got 12 plus 2 is 14 plus 10 is 24, so we're good there. Now you could go down here and put that this distance is 12 feet from point A, which would then make this distance 22 feet. And of course 24 overall. This makes it a little bit easier. So first thing we do is do the sum of the forces in the X. Set them equal to 0, so it's in equilibrium, and we have AX. So we know AX is 0 and BX is 0. So then we do sum the forces in the Y. Set that equal to 0. We've got AY going up, we think it is, minus 8,000 pounds, minus 7,200 pounds, minus 3,500 pounds, plus by. Okay, two unknowns there, so we'll move on to the next bit. So we'll do a summation of the moment relative to A. So we'll be solving for by. So we've got 8,000 pounds up here trying to make that thing go clockwise, which is negative, times 3 feet minus 7,200 times 12 feet minus 3,500 times 22 feet plus by times 24 feet. Leave by where it's at. Leave 24 by equals whatever all that mess equals. Now again, these all go to the other side of the equation and become positive. So that's a good thing. So 8,000 times 3 plus 7,200 times 12 plus 3,500 times 2. Uh, 3,500 times 2, 3,500 times 22, sorry. 8,000 times 3 plus 7,200 times 12 plus 3,500 times 22. So that comes out to 187,400. Pounds feet, right? Okay, then we'll give ourselves a little bit more room here. Okay, so then we divide. So if I could go ahead and write this out, we'll have by equals 187,400 pounds feet divided by 24 feet. The feet cancel out, we're left with pounds, so by equals that 187,400 divided by 24. So you should have by of 7808.3 pounds. We said it was going up. It's a positive value, so it is going up. So that would be by. Substitute that up here in the forces in the y calculation. 7808.3. It was going the right direction, so we don't have to worry about changing anything here. So if we leave AY where it's at, change these over to the other side. So you've got 8,000 plus 7,200 plus 3,500 minus 7808.3. So you should have 10,000. 891.7 pounds. Pushing back up. And that's all we would want for that particular problem. That's 18. So we'll stop the video on that one, and we'll get another one here for the next problem.